So in this video I will be explaining about electron beam machining. Electron beam machining, it is one of the thermal machining process. Electron beam machining is one of the thermal machining process used for heating, melting and vaporizing the material. So and it is also used for drilling, cutting, annealing and welding. So this is basically what is electron beam machining. So let's look at the schematic diagram. So this is the diagram or the basic schematic sketch of electron beam machining. This whole apparatus is arranged in a vacuum chamber, and there are various parts in it, starting from the electron gun which emit the negative cathode electron emitting element, which is attached along with the electron gun. There is an on the bottom part, it has an electron emitting filament. From that high high velocity beam of electron will be emitting, and this whole component, it is starting with electron gun, then it is accompanied by a grid cup. From that grid cup, the electron will be emitting because there is an electron emitting filament inside it. Coming downwards, there is an anode, positively charged anode, and followed by a magnetic lens. So the electron beam emitting from the grid cup or electron gun will come straight through the anode, followed by a magnetic lens. Finally, the divergence. Finally, the high divergent electron beam get concentrated at the workpiece, and which cause machining. And the workpiece is placed at the very bottom workpiece, and so these are the basic components inside an electron beam machining. So how does this work? How does the basic principle of process in an electron beam machining? So first of all, the mechanism of material removal is simply by melting and rapid vaporization, because that's what happening at the workpiece due to the high velocity electron beam. So the mechanism of material removal is basically caused is by two methods or two things: melting and rapid vaporization. Then what? Metal removal process is by high velocity focused stream of electron, right? Because there is a high velocity focused stream of electron is coming from the electron gun, which cause the machining or melting. As electrons strike, the kinetic energy is transformed into thermal energy. The electron which is traveling with a very high velocity, of course it should have a kinetic energy, right? So we know energy should be conserved. So after collision, that kinetic energy with which the electron is moving is converted into thermal energy, and this thermal energy is what which causes the machining, melting and vaporization. Okay, so high voltage is applied across a cathode filament. Thermoionic emission of electron take place. There is an high, we know from the electron gun or that grid cup, that whole apparatus is from which the electron beam is coming, right? That apparatus, that cathode filament, electron emitting element, is there is a high voltage applied across it, which cause the emission, thermoionic emission of electron take place. Okay, that's what caused the high velocity beam to produce. The high voltage is applied across this cathode element. The annular anode attracts electron beam and get accelerated. As I leave the anode section, it is achieving half the velocity of light. After passing through after this electron gun or electron emitting element, it is followed by an anode. This anode is a positive charged particle, so it will be attracting the negative charged cathode, so which causes further attraction or pulling force downwards, towards workpiece, in the downward direction, because it is of opposite charge, cathode of negative charge and anode of positive charge, so it will be attracting downwards. So it causes to pass through the electron beam due to the sign of anode or charge of anode. The electron beam is forced to pass between the anode plates at the both half, and this, after passing the anode, it is followed by a magnetic lens, which is also placed at the both the half. So this magnetic lens is what, so the magnetic lens which will cause the convergence, right, which will avoid the divergence. So magnetic lens shape the beam and try to reduce the divergence. So the electron beam passed between the anode is forced to converge at the workpiece due to the magnetic lens placed at both the half. So the maintenance of vacuum, okay, this whole thing, this whole apparatus, whole working module has to be placed in a vacuum state. It has to be worked in a vacuum condition, and that vacuum state is achieved by a rotary pump and diffusion pump. That vacuum, okay, that vacuum phase inside the electron beam machine is placed by caused due to the rotary pump and diffusion pump arrangement. So that is essential, because why this vacuum state is essential, just because the electron cannot lose energy, not to have the same energy from the emitting part, from the electron emitting filament to the workpiece. I mean, it should not lose an energy, it should be in the vacuum phase. And the workpiece to be machined is placed on the electron beam, right, because the electron beam is coming from the top part to the downward direction. So the workpiece should be placed at the bottom part, okay, it should be placed below the electron beam. So after the impingement of the kinetic energy of the electron absorbed by the workpiece results in heating, right, we know the kinetic energy is converted into thermal energy. So after the heating, after collision of this electron beam, the kinetic energy which is possessing is converted into thermal energy, and this thermal energy what cause the heating effect, melting and vaporization, which cause the metal removal or machining. This is the basic principle. Okay, the kinetic energy is converted into thermal energy, and this thermal energy is causing the machining. It could be melting, heating, vaporization. So that metal removal rate is due to the thermal energy, which is converted from the kinetic energy. Various process parameters, okay, what are the things that cause the basic working or machining of this working of this electron beam machine? Various parameters are beam current. So beam current is simply the current produced, electron beam current produced from the electron emitting element, because there's a high velocity current of electron is flowing from the electron emitting filament towards the workpiece, right. Then it's a pulse duration, energy per pulse, lens current, spot size, and power density. These are the various process parameters which cause the basic machining effect in the electron beam machining. And this point is repeating that kinetic energy is converted into heat energy, and the metal MRR is simply metal removal rates, and metal removal rate increases with the increase in beam current. So metal removal rate increase with the increase in beam current, pulse duration, and energy per pulse. So these are the three factors which basic important parameter which cause the metal removal rate. Okay, not to have to achieve high metal removal rate, you have to deal with the beam current, pulse duration, and energy per pulse. Okay, these are the three main factors cause the metal removal rate. There are also various other factor parameter for metal removal rate, such as beam current, pulse duration, high energy density. So let's look at beam current. What effect does it cause? Okay, when beam current increases, the energy per pulse increases, which would increases the metal removal rate. So if I need to achieve a much better metal removal rate, I have to increase the beam current. Simple as that. Then what is pulse duration? Okay, pulse duration also causes the depth and diameter of the machining spot. Okay, it affects both the depth and diameter. So longer the pulse duration, the wider the hole and deeper the depth. Okay, this is what caused due to pulse duration. And finally the high energy density. So high energy density of the electron beam, what does it cause? Simply increase in high energy density cause increase in the metal removal rate. So all these things are directly proportional to the metal removal rate. If I increase any of these parameter alone or together, would simply increase the metal removal rate. So next step is how to calculate the metal removal rate. If I have various parameters given, if I know the area of the hole or the speed of the cutting, so how to find the metal removal rate? How do you find? So we find by simply using this formula. So metal removal rate is area of the slot or hole into speed of cutting. So suppose I need a particular dimension of hole to be machined. I mean, that is my goal, or that much area of the slot. If I need to machine, I need to know how much. Okay, we have to substitute it. So area of the slot or hole in the speed of cutting. So the product of this will give the metal removal rate. So speed of cutting, how do you find? The thermal velocity occurred by the electron of the work material is due to the electron, that is V. Okay, that V is It is the thermal velocity. Speed of cutting means simply the thermal velocity acquired by the electron. We know the electron beam is having high velocity, which is emitting from the electron splitting filament, right? So this high velocity V is simply defined by the formula root of 2 kb T by m. So what is kb? Simply the Boltzmann constant. M is the mass of one atom of work. Okay, we have a workpiece, and it could be any of any material, right? It could be an atom of aluminum, it could be atom of copper. So whatever it is simply the mass of one atom of work. And T is a rise in temperature. Rise in temperature, not the final temperature, initial temperature, is a rise in temperature. How much change? Okay, suppose 30 degree to 40 degree, so the rise in temperature is 10 degree, right? So T is the rise in temperature. So V is square root of 2 kb T by m. So I will get the thermal velocity acquired by the electron of the work material. Okay, next is the energy density and power density is basically it is controlled governed by the energy per pulse duration and spot size. Okay, it basically depends on what size of you need to be machine, spot size, right? So spot size on the other hand is controlled by the degree of focusing achieved by the electromagnetic lens. We know that electromagnetic lens is finally causing the convergence, right? So that spot size, how much spot should the beam to be machined is simply determined by the convergence or focusing of electromagnetic lens. Okay, so next is what is heat affected zone. We know it causes heating, right? This thermal energy will be causing the heating, vaporization and melting, right? So what is heat affecting zone, or how does it affect? So this is a simple diagram, or the effect of an heat affected zone, so caused by the melting of a workpiece. So there will be a diameter, that's a whole diameter of the damaged layer, and there's a cavity found inside it. This is a simple effect caused by a electron beam. So what are the effect, or what are so heat effective zone is less than 0.25 mm deep. The effect caused by the melting is simply less than 0.25 mm deep. Only that much area or depth will that heat effective zone is extended. So what does heat effective zone consist? It consists of a thin layer of recast material which would decrease the structural integrity of workpiece. So what is a recast material? So recast material is simply the layer. When you melt a material, it will be in molten phase, right? So if you do not remove the molten phase, that material, same material would be solidified to the actual structure. It will form another layer of a new grain. So that is simply recast material. So they will decrease the structural integrity of workpiece. Initially it was having a structural integrity. You will be heating and you will convert into molten stage, and if you do not remove the material on time, that molten material would solidify and form another layer which of low structural integrity, or which would decrease the structural integrity of the workpiece. So the amount of recast material, how much material will be formed, depends on the pulse duration, thickness of the plate. Okay, we will be having a workpiece of various thickness, so these are the factors which cause how much. So the amount of recast material depends on the pulse duration and thickness of the plate. So this is all about the electron beam machining. Okay, the thermal machining process used for machining.